Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at SDXL-Turbo. Okay, so it's a new, image generation model that helps you generate images with, blazing fast speed. You do not have to wait for 40 or 50 steps. It has now drastically reduced when it comes to number of steps when we work with the diffusion models. Now, only in one step, you can generate photorealistic images using SDXL Turbo. So we're gonna cover, the theoretical nuances, and we'll see some of the mathematical intuition behind HDXL Turbo model and what kind of techniques Stability AI have used, to train this model, which is really setting the standard now when it comes to image generation ecosystem of generative AI, where you can generate images while typing the prompt, and which is really impactful. We'll go through the demo. We'll also see how we can use SDXL Turbo programmatically in a Colab notebook through probably a Gradio application as well. And then we'll also understand from their technical report. I've done a bit of study of that, and then I will explain that what kind of techniques they have been using under the hood. So let's get started and see how we can work with SDXL Turbo. All right, so you can see they have dropped a demo on Clipdrop. So by the way, Clipdrop is hosted by Stable Diffusion, where they have other tools as well, where they you can use it, try it out yourself, like remove background, etc. To remove BZ. And by the way, if you don't know about Stability AI, it's a British-based startup, and there are a lot of problems going on right now with Stability when it comes to their management and leadership. Right? I think there are talks going on about selling the company as well. So I really don't understand. Is it not good to make a lot of money, for the investors? I don't know. I mean, what happened with OpenAI, in last few weeks, and now with Stability AI, it's surprising. I don't know what's happening with the safety, AGI, etc., and a lot of complexities. But you can find out here they have something called SDXL Turbo beta version. Of course, it's they just dropped it recently. It says real-time text to image generation. Now, see, if a year back when we were working with the stable diffusion in last year around summer, you know, uh, we we used to see that it used to take 50 steps at least, right, to generate a good quality image. Now you can start writing here. Let me just click. It says enter your prompt, and I'll say, uh, uh, let's say, scenic, and see I'm typing right now. I've said okay, scenic, and you can see it started generating the images. So I'm saying scenic mountain view, and you can see that it will give you a scenic mountain view, which has a watermark of stability. That's fine. It says scenic mountain view. I'll say uh, night sky or something like that. Okay, and you can see such a beautiful image that it generates in real time while you are typing the prompt, which is fascinating to even try it out yourself. And you can see where we are now heading. We are heading real time generations, and this is happening with image generation. This will happen for video generation as well. I am pretty sure that video generation is now the next big thing when it comes to generative AI, because we are talking about multimodalities of data. We have seen that with recently Stable Diffusion has come up with some couple of models where you can generate 2 or 3 seconds video, but there are other models they are working on which will help you generate 3 to 5 minutes video as well. They will release next year sometime. So you can just see how fascinating it is. You can let me just remove. I'll say some other prompts. A guy is eating banana or something, or what is that? Okay, let's see that. And you can find out a guy is eating banana. Okay, I mean real time, right? Fast. You can customize it programmatically. You can do a lot of things, and that's what we're gonna do here. So let me immediately open a. Let me just open Colab here. We're gonna write something in Colab notebook, and this is fine. And you can find out the Hugging Face repository here called SDXL Turbo, which has a license of NC community, SAI NC community. So please have a look at licenses before, if you are using it in commercial settings or for enterprise. You have to look at that licenses, read through it. Then you have your model card, which explains how they are using. And this is important, guys. It uses a method called adversarial diffusion distillation. Okay. See, if you really want to understand how diffusion works, you should know how GAN works. Okay, it's important of having understanding of generator and discriminator, because ADD, adversarial diffusion distillation, is not much different than what we have seen in the earlier method. Now imagine this as a student model and a teacher model. So when you used to take 50 steps, when we used to work with stable diffusion model, imagine that as a stable student model. And now turbo, imagine this as a teacher model, student model. The earlier one was a teacher model. Now when you used to take 50 steps, student model can learn it fastly, can understand the output of it, all of the generation techniques, and then it can synthesize, using different techniques that they used in adversarial diffusion distillation, which has some noise, which uses discriminator for validating it for faster responses. And also, I'm not going too technical into it, but you can read the technical report. Let me just open it over here. You can find it out on uh, here. You can read new distillation technology enabling single step image generation, uh, reducing the required step count from 50 to just one. You can read the paper over here on Squarespace, which has been hosted. You can read it. Fantastic, right? And I can see they're talking about a lot of GANs, etc. You can go and you can see that same the teacher and the student that I was talking about, right? Because I've done a bit of study on this, and you can find out they will also explain the same way, the student model and the teacher model. That's how a very traditional way of explaining GANs. You can find it out over here. And there have been discriminator have been used forward diffusion process. You can read through it and understand in more detail, the adversarial laws, etc. Now, not a big paper, by the way, only 15 to 16 pages with a lot of references. Now, coming back to uh, how we can use it programmatically, we'll use the diffusers library. So let's use diffusers and start coding and see how we can, use SDXL-Turbo. Okay, so what I'm going to do here is I'll change the runtime. So let me just change the runtime. Let's go with T4 GPU. Okay, and I'm connecting to runtime. I'm going to use GPU. I'll just make this. Let's first try with GPU and then we'll try without GPU and see if that, if it's able to inference, through the model weight. So what I'm going to do here now is let's SDXL Turbo. Okay, fine. Now the first thing we're going to do is we're going to install. So let's install pip install diffusers, and we need transformers as well to work with. And then let's have accelerate and upgrade. Fine. So these were the requirement. You can also, this would have done hyphen q, to restrict that. But anyway, let's start writing some code here. So what I'm going to do now is import the library. So from diffusers, import, and we're going to use auto pipeline. So auto pipeline for, let me see. What I'm going to do now is auto pipeline for image, for text to image. So we're going to use this pipeline, which is auto pipeline for text to image. And then I'm going to use torch. So import torch. That's it. So these are the required library that we have to use. Now the next is, let's create a pipe variable to initiate the pipeline. So I'm going to use this. By the way, I'll just do hit enter and I will remove everything which is inside. Okay, it's using the stable diffusion 1.5 version. Now from pre-trained, this is how you use, right? And so what I'm going to do now is, let's use this model. Perfect. We got the repo from Hugging Face, the model path, and torch T type. I'm going to use float 16. So torch, yeah, this is fine. And let's don't use auth token. We don't have to use that. It's not a restricted kind of a model. What I'm going to do is variant. So variant, and I hope it should have an arcs of variant, and I'm going to having variant of floating point 16. So FP16. Okay, and this looks nice. And then we pipe that to CUDA. Okay, so pipe.to CUDA, fantastic. And you can see it says fetching 18 files. I've been fetching some models, across some configs, some models, the tokenizers from Hugging Face. It will take a bit of time. You can see it says 1.39 gigabytes and then 5 gigabytes here. So it will take a bit of time. It's downloading the SIF tensors, which is the right way of saving model weights nowadays, and that's why it's safe. Your tensors are safe, by the way. Okay, it helps you in a lot of different things when you use safe tensors. When you compare that with bin and other formats of saving model weights, it helps you from adversarial attacks as well, in some context. Now let it load, and then what I'm gonna let's do a pipe here and see. So what I'm going to do is pipe, and it will show you the model it has loaded and every other things which is related to it. The scheduler, you can see it uses Euler ancestral discrete scheduler. Recently I've created a video on LCM LoRa where we have used LCM scheduler as well. So these are the topics that you can find out in my previous videos. I have a separate playlist for image and video generation where we have more than 10 videos already. So please have a look at that playlist as well. Now what I'm going to do here is, let me have time thingy. So I'm going to have time, and let's have a prompt, a photo of an astronaut riding a horse on. So this has been used a lot, but I'm going to use a scenic mountain view in the night sky. This is my prompt, and now I'm going to have image. So let me just image, excuse me, image equals, and here I'm going to have pipe, and inside pipe I will do a few things. So prompt equals prompt. I'm going to keep my prompt as prompt because we have a variable name prompt, and let's have a number of inference steps. I'm not going to make this 50. I'm just going to make this 1 or 2 or something like that. Okay, so let's first try it out with 1. So number inference steps equals 1, and then goes your guidance scale. It can be positive, it can be, so 0 is recommended to keep 0, but if you are using negative prompting you can tweak that value. I have covered that in detail in my LCM LoRa video. You can find it out in my image and video generation playlist. Now guidance scale, and now let's do images and the index 0, the first one, and then I'm gonna do, and you can find out the only one step, and it took us 2.92 seconds of wall time, and you can see the total time of CPU times at 1.1, so around 1 second, guys. It's fantastic. It's really real time. Now I'm going to do the image, so let's see, and you can see a beautiful image out there. Don't have to waste your money on mid journey now. Okay, you don't have to waste your money on mid journey or runways image generation model. Open source is the deal, guys. Deploy it and use it. If you don't want to deploy it on cloud for your customer, if you want to use it yourself, just use it in collab or use it in your local machine if you have at least decent compute power. Let me do one thing. What I'm going to do is, now I'm just going to but anyway, you can try it out yourself, how much time it is taking on CPU as well, because right now we are running on GPU T4. You can see on Colab T4 that we are running it, but you can find it out, right? Let's make a change here and see. Uh, an AI, or let's write a humanoid built using AI, smiling with kids. And let me just make number of inference steps 2 to see if there's any difference. And you can use my previous videos where I have seen how to track it for different steps as well, and find out the quality enhancement. And you can find out, right, the fingers, the diffusion model struggles with fingers, by the way. Even Midjourney struggles with fingers nowadays. Even if it's nowadays with version 5.1, 5.2, even they are struggling. I work day and night out with image generation models, but fingers is a problem, and you can hide that. Of course, you can put some flags to only look at the upper body and hide some specific things like fingers or whatever you want to do that. But you can find out number of steps. Let me increase it to 5 and see. So you can see what I'm showing. You can start from one step and you can incrementally increase it to find out the You can even for 5, right, you can find out it took around 1.17 seconds. So what I'm showing you is that it's good for photorealistic images, where you want to capture something, but it might not be good where humans are involved. Okay, with this kind of steps, you have to increase these steps for that. But this is fantastic, to be honest. So this is a great step going forward when it comes to generation model, and this is what it's showing you, or it's giving you direction that you should invest your time in learning these technologies, because this is what it's going to be future of technology, guys. Generative AI, there's no doubt about it. People can say it hyped and all, but it's fundamental technology, to be honest. It's not much different from what we used to do with artificial intelligence or with natural language. Just because we have high compute power and better data availability and way of training these LLMs, language models, after transformers, and also this is the reason. But it's happening, right? AI is an old technology, so I'll recommend you invest your time, learn this technology, and solve problems, the real world problems that you face. And of course, be careful with a lot of other things that we talk about: the data protection, privacy, copyright infringements, etc., right? So I think this is what, I wanted to create a short video to show you that how you can use SDXL on both. You can try it out here on, not here by the way, on the Clipdrop. You can try it out for your testing purposes. You can also do it programmatically in Colab Notebook. You can deploy this model on SageMaker or Azure ML or Vertex AI, whatever you are using. And you can also deploy this as an application through Docker containers or whatever. So let me know if you have any comments. I'll be more than happy to help you. That's all for this video, guys. I hope you learned that how you can programmatically use Stable Diffusion XL, SDXL Turbo, through Colab Notebook, and you can use it. You can also deploy it on SageMaker or any other hyperscalers, to use it as an API endpoint, to generate images faster. You can also build an application on top of it, and there are a lot of possibilities that you can do with it as well. And there are a lot of integrations, in Automatic 1111 and a lot of other tools that we have. They will probably integrate this. They would have integrated this as well, I think by now. But I think it's not slowing down, right? If you look at the generative AI space, everything generative AI, it's not slowing down. It will only go upward, and a lot of developments are happening across the modalities of data, whether it's images, videos, text. Mainly in the healthcare, we saw a large language model called Meditron recently, which was built for, built on top of, healthcare related or medical related text data kind of a thing. So it's not slowing down. I think you should also start upskilling yourself when it comes to this technology. And this is one of the channel that you can use, of course, with other channels as well on YouTube. So I hope you enjoyed this exercise with Stable Diffusion Turbo, and the notebook will be available on my GitHub repository. I will give the link in description, and I also give the links of HDXL Turbo, of Hugging Face, etc. If you like the video and if you like the content I'm creating, please hit the like icon and subscribe the channel if you haven't subscribed the channel yet. Do share the video and channel with your friends and to peer. You can also reach out to me through my social media channels. Thoughts and feedbacks are welcome. Please drop your comments in the comment box. Thank you so much for watching. See you in the next one.